All right, let's do some Mathity-Math. We got a four-part problem here, A, B, C, and D, and let's just go ahead and tackle it step by step. So part A says identify the equation of the vertical asymptote of the function. All right, to find the vertical asymptote, we just go to the denominator. And essentially, we're trying to figure out where this function can't work. In a hard and fast rule we have in math is you never divide by zero. So we're trying to figure out how this rational function would divide by zero. And it would divide by zero, if this denominator became zero. So what makes this denominator zero? You could probably look at it and figure it out, but the procedure you want to follow on this one is you just want to set your denominator equal to zero and then learn what makes the denominator zero, so then you know what I can't use or what would make my vertical asymptote. So I just say, all right, I got x plus 1 is equal to 0. I got to isolate this x, so I subtract 1 from both sides, and I find, well, x is -1. Voila. And this is the equation of a vertical asymptote. This is a vertical line, and it's at -1. Now, if you want, you could actually go ahead and skip on down to the graphing part and just see what that looks like. What that means is I go back 1, and I'm just going to dash this in. I'm just using my highlighter so it's easy to see. There you go, and that's where my vertical asymptote is. That's where my function will not go. Okay, here we go. The next it says, identify the equation of the horizontal asymptote of the function. All right, when we look for horizontal asymptotes, there's a first step and then there's 3 rules. So the first step is you want to find the term in the numerator with the highest degree. So this is degree 0 and this is degree 1. So I found that term. Then you want to find the term in the denominator with the highest degree. So this term is degree 1, this is degree 0. So these are my 2 terms with the highest degree. I can highlight these just so we know what we're working with. So for horizontal asymptote, you only work with the terms with the highest degree in the numerator and the denominator. Now the next 3 rules are for horizontal asymptote. Okay, so if the first rule is this, if the degree of the numerator is smaller than the degree of the denominator, and we call that bottom heavy. So if the bottom degree is bigger, or if the bottom degree is heavier, if it's bottom heavy, we would say y equals 0. Okay, we would say the horizontal asymptote is y equals 0. But that's not the case. Okay, if the degree on top were higher, if it were top heavy, if this were the bigger degree, if it were top heavy, then we say there is no horizontal asymptote. But again, that is also not the case. In this case, they are equal, and if they're equal, your horizontal asymptote follows this path. Y is A divided by B, where A is the coefficient of the term you're looking at, and B is the coefficient of the term in the denominator that you're looking at. So if A is the coefficient of the term in the numerator, we'd say, well, A is -2, and we would say B is +1. -2 divided by 1 is 1. So we know Y is -2, and that is the equation of a vertical line, and that is the equation of our vertical asymptote. Our horizontal asymptote. That is for horizontal asymptote, as you can clearly see right there. So for our horizontal asymptote, if it's -2, I'm just going to go ahead and draw that in now, because I know I'm going to be drawing here. You can see it, part D. So my horizontal asymptote lives at -2. And this is Y equals -2. You know what? I'll go ahead and write that in there just so we don't forget. So this is my horizontal asymptote, and it's Y equals -2. This is my vertical asymptote, which is X equals -1. There you go. Okay. For part C, we need to choose 6 inputs and find 6 outputs, and we're going to use that to graph. Okay? But we want to be smart or clever about how we choose these inputs, because hypothetically you could choose, anything you wanted, but we kind of want to choose the numbers that are easiest to work with, and just make sure those numbers don't, hit our asymptotes, because that's where our function doesn't exist. So a good strategy here is to choose 3 points that are on the right side of your vertical asymptote, and then choose 3 points that are on the left side of your vertical asymptote. And that'll show you where your function lives on either side of that vertical asymptote. So if my vertical asymptote's at -1, the first point I'm going to choose is 0. Then I'm just going to go over 2 and then over 2. That'll give me 3 points on this side to work with. And then I'm going to do the same thing on the other side. So if I'm at -1, I'm going to go to -2 and then go to -4, -6. And you can really choose any points you want, but I want to be strategic about this so I can make my life easier and go from there. Okay, so first things first, I'm going to sub in a 0. So if I substitute in a 0, this 2x, well, what is -2 times 0? That's 0, so I'm going to get 9. And if I sub in a 0, 0 plus 1 is 1. And so that equals 9. So I know that if I input a 0, my output is 9. And I'll go ahead and graph that now because I'm going to know I'm going to be going there. So let's get it going. Since I go, I'm going to use a bigger marker so I can really show these dots. So I go over 0, so right there, and I just go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bump. There's a nice dot right there. Okay, that's 1 point. Let's do another. If I input a 2, well, -2 times 2 is -4, which is like saying 9 minus 4. 9 minus 4 is 5. Okay, and let's see here. If I substitute in a 2, 2 plus 1 is 3, so I just get 5 over 3, which is the same as 1 and 2/3. Okay, so I go over 2, 1, 2, and I go up 1 and 2/3. So that's about, not too big and fat, right about there. It's about 1 and 2/3. Okay, so we got 2 points. Let's keep it going. If I plug in a 4, well, -2 times 4 is what? -8. 9 minus 8 is 1. Okay, plug in the 4. 4 plus 1 is 5. Okay, so I got 1/5. Or you can say 0.2 if you want. That's as you like. So it says I go over 4. 1, 2, 3, 4. And only up 1/5. So I'm right next to that x-axis. Okay. And what you can see here is this function, it kind of is getting boxed in by our asymptotes. And what's going to happen is it's going to push up here and always push up and slide left, and it will approach that -1. And then down here it's going to keep moving right and slide down and approach -2. And we'll draw that next, okay? All right, let's keep putting in some points. If I plug in a -2, -2 times -2 is +4, and 9 plus 4 is 13. And -2 plus 1 is -1. Okay, so now we know that if I go to -2, I go down to -13. Fortunately, it looks like my graph was a little too short. No big deal, we can make this work. So I go back 2, and I go down 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's way down there. All right? Okay, keep it going. If I plug in a -4, if I plug in my -4. So -2 times -4 is +8, and 9 plus 8 is 17. And -4 plus 1 is -3. Okay, so this might be a good example when you want to move to a mixed number real fast. So you can just do this on your hands. You can say 3, 6, 9, 12, 15. That gave me 5 holes. So I got -5. And I only got up to 15, so there's 2 left. So I'm at -5 and 2/3. So I go back 4 and down 5 and 2/3. So let me just center up here a little bit. Back 4, 1, 2, 3, 4, and down 5 and 2/3. 1, 2, 3, 4, 5, and about 2/3, about there. Okay, looking good. Last input, and then we're in the home stretch. Here we go. If I plug in a -6, -2 times -6 is a +12, and 9 plus 12 is 21. Okay, and -6 plus 1 is -5. Again, let's just make a mixed number. 5, 10, 15, 20. That gives us 4 holes. And we only got the 20, so there's a 5th left. So you can say -4 and 1/5 or -4.2 as you like. Oops, let me write that there so I can show my answer. Okay, so here we go. ready to do this thing. I go back 6 and down 4 and a fifth. 1, 2, 3, 4, 5, 6. Go down 4 and a fifth. 1, 2, 3, 4, and a fifth. All right. So we have our dots. Now it's time to draw our function. If we think about this, this function down here is really clear. The vertical asymptote is coming down. So what's going to happen is this function down here, it's going to keep going down, 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 and moving toward that vertical line of x equals -1. And then this one, it's going to swing up and curve up, and it's actually going to always approach up to almost hitting y equals -2, and always moving left for infinity. But it never ever hits either one of those asymptotes, but it always gets infinitely closer. Now I'm going to take out my nice thicker pen and really try to draw this. So it's going to look something like that. That's nice enough. You can see I drew my arrows on there to show where it's going. Okay, I can make those arrows a bit nicer for you guys. There we go. Okay, nice. Okay, let's do the same thing up here. So this one's going to push in closer and closer and closer like this, and swing down, 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 down. Swing, 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 swing. It's going to approach that asymptote like that. Okay, and there you go. That is how you graph it. As always, if I was confusing or you didn't understand something, you can ask me a question in the comments below. If you like this video, go ahead and subscribe so you'll be notified when I make more. And yeah, thank you. Bye.